In this video, we're going to look at torque. Torque is an extension or application of force. Torque is the measure of the effectiveness with which a force can cause an extended object to rotate about an axis. So think about pushing a door open. The farther you are from the hinges, the more effective your force is. Okay, so torque is this fun tau sign, pretty T, equals the radius in meters times the force in newtons times sine theta. Theta is the angle between R and F, between your radius and the force. A lot of times theta will be 90, which means sine theta is 1, so it would be just torque equals RF. Okay, now we care about direction with torque. Clockwise is negative. Counterclockwise is positive. There are a couple of ways you can use to remember this. First, curl your fingers. If you curl your fingers counterclockwise, your thumb points up. That gives you the thumbs up sign, which means counterclockwise is positive. Curl your fingers clockwise, and you make a thumbs down, negative. Another way to remember it is if you think about your C's as negative, counterclockwise is 2 negatives, which makes it positive, while clockwise is 1 negative, so it makes it a negative torque. I personally like the second way, but it's completely up to you about how you can remember it. Just remember clockwise negative, counterclockwise positive. All right, when solving torque problems, you're going to need to identify the pivot point, the point at which things rotate around, okay? The point where nothing moves. Sometimes you get the pleasure of picking it or finding it, but usually it's given to you. You're going to identify all the forces acting on the system and their radius, their distance from that pivot point, okay? Now, if you're dealing with a beam or something like that, and it doesn't tell you it has a negligible mass or it's massless or whatnot, that means that gravity acting on that beam is part of the system. You need to find the center of mass of that beam, so the center of the beam, and that is the point at which that force is acting, okay, because all forces are measured from the center of mass. Number 3, sum up your torques. Clockwise, counterclockwise, find them all. Everything that's making you rotate. Often the sum of your torques will equal 0. This means it's in equilibrium. Okay? So basically it's not moving. You may or may not have to sum up your forces in the x and y direction. Sometimes you need it to find your torque. Like you can get one number from the sum of your forces that you need to solve for your torque, things like that. Oftentimes those two things work together very well. Let's look at an example. So a man and a woman are pushing the revolving door. The man's 1.7 meters and pushing with 20 newtons. The woman is 1.3 meters from the center and pushing with 25. Now, if you looked at their forces, you'd say, oh, both their forces are acting in the same direction. Everything's positive. No. Okay, our torques have them rotating in opposite directions. Okay? So, step number 1, identify our pivot point. It's the center. Identify all the forces acting and their radius. Force of the man was 20 newtons, 1.7 meters. Force of the woman is 25, and she's 1.3 meters. Okay? Now, let's set up our sum of our torques. Sum of our torque equals FR sine theta. So the positive torque minus FR sine theta, the negative direction. So our positive direction would be our counterclockwise, which would be our man. So 20 newtons of force, 1.7 meters, times sine of theta. Sine of 90, that's 1, minus 25 newtons of force from the woman, times 1.3, times sine of theta, which equals 1. All right, so we get 20 times 1.7 minus 25 times 1.3 is the sum of our torques. So the sum of our torques equal 66.5, and your units are newtons times meters. Force times distance, newtons times meters. All right, our second question asks us if the two people were pushing with the same force as previously, so they have the same F, and are a total of 2.5 meters apart. Before they were 3, so they're closer together now. How far away would each of them be from the center of the door if it wasn't moving? So if the door is not moving, then the sum of your torque equals 0. So force of the man times the radius of the man times sine theta, which is 1, minus force of the woman times the radius of the woman equals 0. So the force of the man was 20 times the radius of the man minus 25 for the woman times radius of the woman. Now we have two unknowns here, radius of the man, radius of the woman. But we know they're a total of 2.5 meters apart. So if they have a total of 2.5 meters apart, and this is our center, if, let's say, the man is R, then the woman would be 2.5 minus R. Okay, totaling 2.5. So 0 equals 20R minus 2.5 times, 25, not 2.5. 25 times 2.5 minus R. You solve for R, and you get 0 equals 20R minus 62.5 plus 25R. Okay, so let's see. 62.5 equals 45R. So R equals 1.39. So the man is 1.39 meters away, which the woman would be 2.5 minus 1.39, which is 1.11. And that's the radius of the woman. Not too bad? All right, let's look at another example. Second example, we got a beam being held up by a cable and a man standing on the beam. So we find our pivot point is the wall. Now we consider all the forces. We have the man's weight, we have the beam's weight, and we have tension. Okay? And we also have the force of the wall pushing out. So that's not a torque. Okay? We got 3 torques acting. 2 down, 1 up. So we find the sum of our torques. Sum of our torque equals, positive torques are counterclockwise, which in this case deals with our tension. Okay, so that's FR sine theta. So our tension is our force. R, it is 5 meters from the pivot point times sine theta. Theta is the angle between R and F. In this case, 53 degrees. Minus our forces, or our torques, in the clockwise direction. which includes the man. The force of a man is his weight, which is 600 newtons, times his R, which is 1.5, times sine theta, which is 1, minus the beam, which is 300, and we find the center of mass of the beam, which is halfway through the beam. So if the beam is a total of 5 meters, center of mass is 2.5 meters, times sine of theta is 90. Okay, now the beam is not moving, right? It's not rotating, so sum of its torque is 0. So all we have to do is solve for t. Why don't you pause the video and give it a whirl, and let's see if we get the same t. I get t equals 413.2 Newton meters. Okay, so that's the tension in the string. Now the second question is asking, what's the force exerted by the wall on the beam? So we have this tensional force pushing that way. Well, it has an x and a y component. And since the beam is not moving, the inward x component is balanced out by an outward x component from the wall. So this is where that sum of the forces come in. Sum of our forces in the x direction equals 0. It equals the positive x direction, which is force from the wall, minus the x direction of tension, which is tension. And since this is our angle, we're looking right next to it, adjacent, so tension, cosine of 53, cosine of theta. So Fw equals tension, which is 413.2, times cosine of 53. So force on the wall equals 248.7. And there's our second example. Okay, if you have any questions, go back and watch the video again. Torque, it's fairly simple. We're just adding the radius component, but it takes a little while to sink in. Good luck on your homework.